In this video, we're going to find the derivative of tan inverse of x, or define it. And so what we have is that the derivative of tan inverse of x is equal to 1 over 1 plus x squared. So this is definitely different than sine inverse and cosine inverse. Sine inverse and cosine inverse both had a root down here and a minus. So we have no root and a plus. So what the heck happened? Okay. What happened is that when we go to prove this, so we start with y equals tan inverse of x. And so I want to take the derivative with respect to x, but I'm going to switch it back to x equals tan y. All right. Now when I take the derivative with respect to x, I get 1 equals, the derivative tangent is secant squared y, and then a dy dx. And solving this for dy dx, I get 1 over secant squared. All right, we've been through this 2 times already. So what's going to happen is that we don't, it's bad form to, if you're given an equation explicitly in x, to give an answer in y. That's just like disrespectful. So what we're going to do is we're going to use a right triangle to figure this out. So our right triangle is, so if I come here, my angle will be y. This would be x over 1, and tangent is opposite over adjacent. So the opposite is x, the adjacent is 1. And then this missing side would be the square root of 1 plus x squared. Let's see. 1 squared plus x squared. Yep, that equals the hypotenuse squared. Beautiful. Okay, so I want to do secant squared. Well, wait a second. 1 over secant, isn't that just cosine? It is, right? Okay, so let's go ahead and rewrite this as cosine squared y. Maybe that'll be a little bit easier to do from our triangle. So going to our triangle, we want to know what the cosine of y is. So the cosine would be adjacent over hypotenuse, which is 1 over the square root of 1 plus x squared. Okay. Oh, but don't forget, this is squared. So this is squared. So notice what we get. 1 over 1 plus x squared. Ta-da! Pretty cool, right? All right, I think it's cool, but of course I'm a math nerd. All right, so this all came to be from taking implicit differentiation and using a right triangle. So there it is. If I kind of zoom out, you can see the whole stinking thing. All right, now, we do have a chain rule version of this as well. So 1 second. All right, let's go ahead and look at that chain rule version. So what if you have other stuff in here other than an x? Then its derivative will be 1 over 1 plus that stuff squared, but by chain rule, I have to times it by the derivative of it. All right, so these are the 2 rules we're going to be using as we take derivatives of tan inverse of x. So good luck.